Good morning. I'm genuinely sorry that I'm not able to be with you this morning. You know the background and the reasons. And before I start my presentation, I do want to thank you, Richard and Sandra, for all of your help. You've been fantastic, and we did a lot of preparation and had everything in place until I turned up at the airport. However, this morning I'm here to talk about, is there a correlation between sustainable farming and no-till conservation agriculture and conserving environmental resources? I intend to overview this by first standing back and look at what's happening at a world level. So while we need to act locally, we also need to be conscious of the things that are shaping the future for agriculture and forestry. I'll also want to talk a little bit about what's happening in New Zealand with respect to our biodiversity and natural ecosystems and in relation to forestry. There are some long-term trial results from different methods of cultivation in New Zealand, including non-till, that I want to share with you. And I want to introduce you to the cross-slot drill, which was developed here in New Zealand and now is being sold for non-tillage purposes globally. Finally, I want to wrap up by reflecting again on the question posed regarding conservation agriculture and resource use. So let's have a look at some of these global drivers. They're on the screen before you. It includes population growth and demographic change. So while some countries' populations are continuing to grow rapidly, such as India and on the African continent, other countries are experiencing population decline, such as Japan and in Russia. There's also increased trade between countries and also people movements, both in terms of refugees and migrants, but equally in terms of people moving from one country to another to establish new lives. There are huge changes in science and technology, and I'll allude to some of those this morning. The license to operate has been altered by social media, so there is a lot more focus on what businesses do, and if they're non-compliant with the public's expectation, that poses challenges for them and can damage their brand. Water is a huge issue, not only here in New Zealand, but globally. We're actually entering a phase of water deficit, and water use efficiency becomes a critical issue. And finally, there is climate change. All of this happens in the context of a world population moving towards 9.5 billion by 2050. That means that we're going to have to increase food production by 70% and fibre production from wood, trees, by at least 300%. The latter is often overlooked. And we will have to generate this extra food and fibre from less land and with less water. In other words, we're going to have a step change in technology as well as a huge increase in the efficiency with which we use resources. We know that our ecosystems are under pressure, and here in New Zealand, I just want to illustrate that in relation to our birds. We've just had a report produced that indicated that 4 out of 5 of our 168 species are in trouble, and some are on the brink of extinction. That's due to land development, which has removed habitat or modified habitat to the extent possible. It's also due to the fact that predators have been introduced, such as cats and possums and stoats and the Norway rat. I'm privileged to be on a company called Predator Free 2050, which has got the task of eliminating these top 3 predators: possums, stoats and weasels, and rats, and we also tackle cats. The point is, introduced species and biosecurity incursions are causing challenges to our ecosystems. We can reverse the damage, but it requires a focused effort. The challenge is exacerbated by the fact that climate change is occurring. And as President Obama, quite a contrast to the current situation, noted, no challenge poses a greater threat to future generations than climate change. And we can see that in relation to New Zealand's context. The Paris 21 agreement, for which there were 175 signatories last November, aims to keep temperature rises to less than 1.5 degrees by 2050. The current contribution of emissions reductions are expected to result in a 2.5, 2.7 degree rise in temperature by 2050. We can see here on the chart that New Zealand's temperature rise, even by 2035, is likely to be about 0.7 to 1 degree warmer than what it is now. You imagine your own body experiencing a temperature rise of that magnitude. It certainly will impact ecosystems. We will see drier conditions on the East Coast. We will see more storm events, more cyclones, and we just have to reflect on this past week with Houston, Bangladesh, and here also, I understand, in Africa. New Zealand's target is to reduce emissions by 30% by 2000, relative to 2005 levels, or 11% below 1990. Under the Paris Agreement, there are 5-year reviews, and in order to meet that 1.5 to 2 degree target, more emissions reductions will be sought from countries such as New Zealand. One of the solutions is to plant more forest. For example, if New Zealand was to establish 1 million hectares of additional forest, we could offset some 28% of our total emissions by 2030. So this context brings to mind Albert Einstein's quote, "Insanity is doing the same thing over and over again and expecting different results." We confront a world that's changing. The climate's changing, populations are changing, security's changing, and we need to have new thinking introduced into agriculture, the food and fibre supply chains. There are some great examples. Consider this: synthetic food and the Impossible Foods Impossible Cheeseburger, all made from plant. And also, that manufacturing of that product is now printed through a 3D printer. So you can order just in time your hamburger, perfectly presented, excellent taste, low environmental footprint, virtually no emissions. Radical change in food production that is accelerating. We also see it in dairy with synthetic milk. In forestry, we're migrating from forests from timber production and pulp and paper to a bioeconomy, new biomaterials. So every product that can be made from fossil oil can equally be made from the materials sourced from trees, plastics, and so forth. So now we think about forests as being the oil fields of the future. Renewable forest, plantation planted. And in that respect, New Zealand is a world leader. We established our first large-scale plantation forest in the 1930s, some 100,000 acres. Now we have 1.7 million hectares of radiata pine, principally radiata pine, that are harvested at 24 to 30 years of age. They store greenhouse gases or carbon, they protect biodiversity, they stabilise land, they reduce flooding, and they contribute to our third largest export earner. In the future, we should not overlook the importance of forestry, even though it causes tension in relation to water use. The other aspect of climate change, but also pollution of the environment, is the introduction of markets where the polluter pays for their effects. And in New Zealand, we have introduced an all gases, all sectors emissions trading scheme. At present, it does exclude agriculture, but all of the oppositions except the current government are planning to bring agriculture in. That's significant because 49 to 50% of all of New Zealand's greenhouse gas emissions are sourced from livestock agriculture. You can see the prices for New Zealand carbon, what we call New Zealand units, is up around $17, $18, and the trajectory is to move towards $50 by 2030. So carbon pricing, the pricing of pollution, is going to help to incentivize behaviour change by those that are causing the adverse effects on the environment. The counterfactual is that those that look after the environment, those that conserve water, those that store carbon, will be beneficiaries of this change. So we will see this transition to ecosystem services markets and the pricing of what economists call externalities over the next decade begin to accelerate. We will also see an acceleration in the use of precision technologies, essentially driving greater resource use efficiency. Things like drones and drills on your tractor that are connected to GPS that read the different types of soils, alter the sowing rates, etc. You're familiar with it, but we're going to see, powered by the internet, you'll notice the little diagram up on your left-hand side, how smart connected products are transforming competition. That's true in agriculture and fibre forestry as well. In our case, when I was at Scion, we were using remote sensing to count the number of trees in the forest. We could determine their shape, as you can see in one of those pictures, and we could manage the forest more precisely and more productively. The other big change that is coming is performance monitoring of your environmental impacts. And here's a great example from Icebreaker, a New Zealand company for merino. They have what they call a BAA, B-A-A code, which enables a consumer buying an apparel item to scan that and track back to the farm from which the merino wool was originally sourced. The farmers are available on YouTube and describe their systems, and you can gain confidence about the way they've managed their farm properties. We will see more third-party verification and authentication of environmental claims. And I was privileged when I was CEO of Landcare Research to be involved in establishing a new certification scheme for greenhouse gases called Carbon Zero. If you want to follow that up, you can read about it in the website here under Enviromark Solutions. The axiom is true. If you can't measure it, you can't manage it. So one of the things that's going to drive improved environmental performance, improved use of natural resources, is the ability to measure and manage them actively. The other concept that is developing is a progression towards what is called a circular economy. Your waste becomes somebody else's opportunity to generate a new product. So waste reduction and waste elimination is the target. The aim for manufacturing in UK by 2050 is to have no waste. And we see leading companies like Procter & Gamble and Unilever and others, the Plan B group, that are actively looking to eliminate their waste. And you in agriculture can do likewise. The manure provides a source of methane, provides a source of nutrients that can be used and reduce the adverse effects on the environment. As well, we're seeing in the circular economy green walls, green roofs, and also incubators where plants are grown 24/7 under controlled conditions for vegetable production and so forth. So again, lower environmental footprint or co-benefits generated such as green roofs in cities. I also want to mention about the importance of gene technology, because this is very significant. Fundamental improvement in the water use efficiency of plants, the nutrient use efficiency, the efficiency of animals is driven by genetic improvement. And we have a new set of tools called gene editing, enabled by CRISPR technology, for example, that enables us to precisely identify the genes that are controlling traits of commercial interest for us. They're not transgenic. In other words, they're not a GMO in the sense that people associate genetic material from a different organism being introduced to the species of interest. This is done within the genome, and it offers great potential to improve the efficiency and the productivity of agriculture. We also have a migration to thinking about the way that we use our land more, not just at a farm scale, but at a landscape scale. So we're designing the landscapes and we're integrating different types of enterprises, forestry, pasture, cropping, into that landscape to maximise the use of the natural resources and minimise the impact. And there are great tools becoming available, no doubt many here in South Africa, that enable farm and catchment level planning. Here you can see in the top a 3D dimensional picture of a Waikato farm. That's about 100 kilometres away from where I'm speaking today, which is enabling the farmer to identify best land use for particular purposes, and to control water runoff, and to establish biodiversity, native species planting, forestry in places which will not necessarily reduce production from the pastoral system, but will enhance outputs overall. And we need to take a long-term view. Here in Rotorua, the target is to reduce nitrogen leaching into the lakes by 2032 by 170 tonnes per year, almost 45% of the current level of nitrogen going into the lakes. Here we can see where planning has occurred for a 2050 scenario, and you'll notice the changes in land use over time to lower leaching activities. And of course the challenge is to change your enterprise mix while at the same time retaining farm profitability. Internationally, we see many examples with co-cropping and multi-cropping. In Brazil, where you've got different species, you can see that on my right. Also, you can see in India where wheat and trees are grown together, and here in New Zealand where ginseng is grown as an understory crop with radiata pine. So, the world is changing really fast. Natural resources are under pressure, the climate is altering, and we need new ways of thinking to design our systems in order to retain profitability and use water and soil on a sustainable basis. And here I want to switch to talk about some of the trials in New Zealand. The Foundation of Arable Research, and I want to acknowledge the CEO, Nick Pike, for providing me these slides, is a levy-based organisation. In other words, the arable producers, of which there are some 2,700, pay a fee on crop harvested or seeds purchased, and this goes towards applied research and technology transfer. FAR undertakes research on behalf of for farmers or buys it on their behalf. They have established a long-term trial at a place called Chertsey in the South Island, and also a counter in the North Island. Now they have over 10 years of data, and they run regular field sites at workshops for farmers at these sites, as well as generate best practice manuals such as the one you can see before you in relation to farm environmental plans. In relation to cultivation methods, you can see here on the screen different types of tillage where there's ploughing, 2-pass top down, 3-pass top down, and no till, the John Deere disc drill and the cross slot drill. And you notice that on the outside column, on my right is the soil disturbance rate, which is a measure of how much the soil is turned over. And on this next chart is the yields under those different treatments for the last 3 years, 2013, and just to illustrate, for wheat, peas and wheat through to 2015, and under irrigated and dryland conditions. The key take home from this is that no tillage methods were best in terms of yield on the dryland conditions out of 8 out of the 10 years. And while some of those were not significant, the trend generally was for no tillage to perform better, as you can see here, in dry land conditions. It also competed competitively under irrigated conditions, but the differences were not significant. So it demonstrates that under harsher conditions, water constraints, no tillage performance is very good. And under irrigated conditions where water stress is removed, it still performs at a similar level to the other methods. We also see from this long-term trial the benefits of rotation of crops. So here where we have a pasture break, that under all tillage treatments that help to improve water holding capacity. So the take home here is designing a crop rotation, and all of you will be very familiar with best practice in terms of looking after your soils in order to maximise its water holding capacity. So those are the FAR results. Let's now look at cross-slot. I was fortunate, I was at Massey University in the 1970s and early 1980s as a young lecturer when Dr. John Breaker and his staff in the Department of Agri-Engineering began to investigate direct drilling, no-till cultivation. And they were interested in relation to introducing new pasture species into existing swards, rather than, say, less so than arable cropping. However, they have extended that, and over the years they developed the Cross-Slot into a commercial company and have worked very hard and now are seeing global sales. They're based in Fielding, and I encourage you to look at their website. The essence of the Cross-Slot technology is illustrated in this slide. We can see the T-slot, the inverted T, which results in improved water holding capacity, but also enables co-placement of seed and fertilizer, and quite different to the V-slot and the U-shaped slot. Lots of trials have been done with the Cross-Slot drill. Here's one from Massey University just recently, comparing different no-till methods with the winged opener or the T-slot, having far better emergence of wheat in dry conditions than the other forms. So again, it demonstrates that moisture management in dry conditions is critical to crop success. And that's why cross-slot drills have been taken up in West Australia. Here's a big machine, 9 metres wide in Australia. And in the next slide, you can see a great wheat crop that's been established in West Australia under dry conditions using the cross-slot technology. We also have available cross-slot for small-scale farmers, either pulled by a small tractor or draft animals, as illustrated in the picture here. Again, just to emphasise the importance of soil relative humidity, you can see a comparison in this slide between the different types of no-till disc shape, with the T winged cross-slot providing the best moisture retention in these two experiments. In conventional tillage, they are also using plastic film to cover the ground, also warms the soil up and may stimulate early emergence. But the question, I guess, is if you can achieve water use efficiency with no-till methods, why would you introduce even a biodegradable plastic into your production system? Just a couple of further shots illustrating the benefits of the cross-slot drill. You can see on your right, side-by-side field trial comparisons in North Dakota, the US, with single disc on your left, and in the next one in Germany, where the cross-slot T is on your left and the single disc on your right. So the evidence seems to be that the cross-slot does perform well in a range of different environments. As well, they have done trials investigating the placement of fertilizer. So in this picture, we have the fertilizer broadcast and then the seed direct drilled with the T-slot. And on the right, the fertilizer has been placed down the chute with the seed and placed in the ground. And obviously far, far better performance where the seed and the fertilizer are co-located. So the summary of the trial results with cross-slot drills is in this slide, and I'm conscious that it's relatively small, but just to read for you, under the fire trials, some 23% increase in yield, 13% also in Canterbury for winter arable crops. In the US, some 13% increase in the New South Wales for soybean, a 30% increase over 13 years. In Marlborough, New Zealand, quite staggering increases. That's a dry summer autumn environment in New Zealand for forage brassicas, 40 to 109%. And with winter wheat, some 17%. Now, my purpose here is not to sell cross-slot drills, obviously, but just to make you aware of the technology developed in New Zealand, well proven around the world, and I understand there is an agent in South Africa, and if you want to investigate further, as I say, look at their website. So let's now try to wrap all of this up. Conservation agriculture and the use of resources. What can we say? It's doing the right thing. It's looking after nature, and as they say, if you look after nature, it'll look after you. The trick, of course, is to keep your bank balance positive. As they say, if you're in the red, you can't be green. So here's some things that are influencing and are positive generally for conservation agriculture. Social license. We demonstrate good stewardship of soil, public acceptance is higher. Traceability and verification of environmental performance is increasing, and you should be able to demonstrate that through conservation techniques that your footprint is smaller. Natural capital counting, which is increasing in popularity, should also favour systems that make better use of natural resources and sustainably use those resources over time. The emergence of polluters pays will also be beneficial for systems that have a lower impact on the environment, and regulations now, because of the adverse effects on water quality, water availability, greenhouse gas emissions, are moving to cause either a tax or a price to be placed on those that cause the pollution, and those that generate the positive externalities, in other words, store carbon and improve water quality, should be beneficiaries. In all of this, I haven't talked much about the most important person, the farmer. And you, being at this conference, exploring new information, are critical to the success of conservation agriculture. Things are changing rapidly. You can learn from your farmer peers, and I notice on your website a lot of that occurs in South Africa. That's great. Farmers respect leading farmers and learn from them. You also need to keep a good eye on the science that's happening not only in South Africa but around the world. We should also expect continuous improvement, but we know disruptive change through the internet, through drones and other technology, synthetic foods for example, is going to increase more volatility into supply chains, and so we need to be more agile and adaptive in our management going forward. So well done for being here, and I encourage that continuous learning, curiosity, willingness to change, willingness to challenge, willingness to explore. In summary, global food and fibre demand is continuing to grow. While it's variable around the world, in South Africa, my understanding is that food security is a critical issue, and food productivity and fibre, let's not forget that, needs to continue to improve. Natural resources, especially water, is under pressure, and that's going to drive changes in production systems and methods. Climate change is altering the weather, and while we can mitigate the impacts of climate change, the clock is already ticking for temperature rises, and we're going to have to adapt to bigger droughts, more extreme rain bombs and weather events. New technology, we shouldn't underestimate the value of that and the benefits that it can bring, and huge investment is going into areas, gene technology, 3D printing, synthetic foods, sensor technology, that's going to help us to use resources more precisely and more appropriately. There will be new systems such as circular economy. Your waste becomes somebody else's opportunity. And new materials from forest, for example, that are renewable, low emissions, low footprint, equal functionality to oil are now available. And finally, no-till farming systems, they're proven, they're here to stay, and all the trends suggest that they will continue to increase in the future. So, Chair, is there a correlation between sustainable farming, no-till conservation agriculture, and conserving environmental resources? My conclusion is an emphatic yes. Thank you very much.